Okay, so we're going to talk about how to use the tables in the back of the book. Alright, so for example, one of the reasons that we even bother to get z-scores, and I'm sure I discussed this, is that we want to compare a score in order to kind of, compare apples to apples and oranges to oranges. Because if you think about it, if I have two populations, let's say here's the United States, which is a really bad example of the United States. You're taking a statistics class, we find out that in this area here, the average is an 87. 0.3, which was my average last semester, and this is really bad, but let's say this is California, and I find out that the average in California is a 78.9. Alright? It doesn't really tell you much because you don't know if the tests, obviously, they weren't the same thing. Right? So we need to find out what the average is of everyone to find out is this 87.3 above or below the standard, etc. And so in order to compare these two, we need to put them on the same kind of score, and that's where we use the z-score. So we can compare basic scores on the normal curve. And it also helps us understand probability, right? Because the characteristics of the normal curve. So let's just say we have problem, and I'm starting with handout. Handout 5. Alright. And what I do know from handout 5 is that it tells me that here are some scores on a statistics quiz. What's the probability? It tells me that there are 35, n equals 35. The mean is equal to 7.2, and S is equal to 1.5. Alright, and so if I want to know what the score is, the z-score, and the probability, I have raw scores. I know my scores are 9, 5.5, 4, 8, and 6.5. Wants me to calculate the z-scores and then come up with a probability. In this piece right here, you're going to use the appendix. Alright? So, if I know the score is 9 and I want to know what the z-score is, I have to take 9 minus the mean, 7.2, over the standard deviation, which is 1.5 divided by 35.